All right, hopefully this will be the last video. I'll try not to go too fast or anything, but I know you probably want to finish up your review. Okay, 11. So you got to be really, really careful with this one. Remember from PEMDAS or GEMDAS or whatever we're doing, we have to multiply and divide from left to right before we add and subtract from left to right. So you are not allowed to do 20 minus a half first. Do not do that. You need to distribute, you need to multiply first. So we're going to distribute that negative half to both terms inside the parentheses. So 20 minus. Negative half of 20x is 10x. Negative half times 10 is 5. Sorry, negative 5. Now we're going to combine like terms that we have on the left. So 20 minus 5 is going to give me 15. Now I can start inverse operations. This is a positive 15, so subtract from both sides. Sorry, it's making my 5s pretty weird. I'm left with negative 10x. Make sure you see that part. Negative 10x, and then 40 minus 15 is going to be 25. Dividing both sides by negative 10 gives me that x equals negative 2.5. Kind of a weird answer, so I'm going to check this and make sure everything's working out. So plugging this number back in, 20 minus half of 20 times negative 2.5 plus 10 should equal 40. So using my order of operations, 20 times negative 2.5, let me see what that is. 20 times negative 2.5 is negative 50. Plus 10 is negative 40. So I have 20. I don't know why it's writing so sloppy. I'm really sorry. 20. And then we have negative half of negative 40 should equal 40. Negative half of negative 40 is 20. And 20 plus 20 is 40. It works. Oopsies. What's that random 4 doing over there? Okay. Are the pair of ratios equivalent? How do we know? Well, we can look for some kind of patterns here. So how do we get from 7 to 28? That's times 4. How do we get from 4 to 16? That's also times 4. So that's looking like they're equivalent. Let's look at those cross products. So is 7 times 16 the same thing as 4 times 28? Well, let's see. 7 times 16 is 112, and 28 times 4, 8 times 4 is 32, 2 times 4 is 8, 9, 10, 11. They are the same. So a couple ways I can tell. Cross products, 7 times 16 and 28 times 4 equal the same thing, 112. Or I can kind of look for a pattern. So 7 times 4 is 28 and 4 times 4 is 16. You could also look at how these fractions reduce. 7 over 28, they're both divisible by 7. That leaves me with 1/4. And 4 over 16 is also 1/4. Another way to look at it. Okay, literal equation. That means we have more than one variable. We are not going to get an answer that says x equals 4 or x equals 10 or even x equals 15.2. Nothing like that. We're just going to try to get x by itself, combining what like terms we have. So y equals 2x plus 5. It's just a formula trying to get this x by itself. Inverse operations. So I see a plus 5. I've got to subtract 5. Now what's different from the first couple problems in this problem is y minus 5. These are not like terms. I cannot simplify this the way that I did on previous problems. So what I can do is just leave it y minus 5 is equal to 2x. I cannot combine those. Now, what do we see? What operations do we see? 2 times x is multiplication, so I can divide by 2, and I'm left with x equals y minus 5, all divided by 2. And that's as far as I can go. Same thing with number 14. I've got lots of variables. K equals 1/2 times m times v. We know we have multiplication when we have letters, numbers, all just together with no plus sign or minus sign in between them. We know that's multiplication. So I'm trying to get the m by itself. So we know that m is multiplying by v, so I can divide by v. That would cancel. So k divided by v is equal to 1/2 m. Well, we know that the inverse of 1 over 2 is 2 over 1. So that's going to cancel, leaving m by itself. So m is equal to 2k over 1v, or just v. Let me check my time. Okay, I'm good. All right, evaluate the expression if a equals 10, b equals 4, c equals 2. So all I'm doing is substituting those in. If a is 10, I'm putting a 10 right there. If b is 4, I'm putting a 4 right there. If c is 2, I'm putting a 2 right there. Oops, right there. Using order of operations, I have to multiply before I add and subtract. So this is 10 plus 8, 18. Notice on 16, 17, 18, there isn't an equal sign. It's not an equation. Whoa, it's not an equation. I am simplifying. So just combining like terms. We know that minus a negative means positive. My like terms, 2 and 4, so that's 6. 8x and 5x, and that's 13x. Notice I'm not adding to both sides, subtracting to both sides, none of that, because there are no sides. There's no equal sign here. It's not an equation, it's an expression. Okay, same thing down here. Distributive property. 3 times 2w is 6w. 3 times 5w is 15w. Like terms, they have the same variable. 6w plus 15w is 21w. And 4 plus 7 is 11. Exponents. We told you they were coming back. You're never going to get rid of them. So what this little 2 means, right up here, this exponent of 2, means I'm going to write what's inside of this parenthesis 2 times. Multiplication. This little 3 means that I'm writing what's inside of there 3 times using multiplication. 3x to the 4th y, 3x to the 4th y, 3 times 3x to the 4th y. Multiply all the numbers together. 2 times 2 is 4, times 3 is 12, times 3 is 36, times 3 is 108. So 2 times 2 is 4, 3 times 3 times 3 is 27, and 4 times 27, I'm just checking myself. 4 times 7 is 28, yeah, 108. Just count your x's. 3 here, 4, 4, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Same thing with y's. 2, 4, 5, 6, 7. All right, sorry. The next 2 are going to have to be in another video. I'm sorry.